In this video, we are going to try to figure out how to find the equation of a line given 2 points. Okay, so just to kind of refresh a review of what we did a little bit, to find our equation, we're looking for this equation, and we can use the point slope formula, the form, to create the slope intercept form, or you can just go right into the slope intercept form. So I'm going to do the slope intercept form. The last video had a similar situation where we had a point and a slope, and then we showed 2 different approaches to figuring out this equation. One was using the point slope form and one was using the slope intercept form. So I'm going to opt for the slope intercept form kind of on the rest of these, but absolutely you could be using this method just as easily as you could this method. So here's the biggest difference between this problem when they give you a point and a slope and this problem that they don't give you the slope. You find the slope. That's it. So once you find the slope, you're literally the exact same situation you were here. We're going to use our slope. We're going to plug in our x and our y, and then we're going to figure out our y-intercept, and then we have everything we need. Okay, so first thing we need is slope. And that's pretty much the situation. That's literally the only difference with every single one of these problems is how they give you the slope or how they give you the information for the slope. Either they tell it to you or they imply it. And so if we have points, we can always figure out what the slope is. So we need slope. So to find our slope, we are going to do change in y's over change in x's. So our y's go from an 8 to a 0. So we are going down 8. Our x's are going from a 0 to a 5. So we are going up 5. And there's our slope. Okay, so now we're jumping into the y equals mx plus b. And we know currently our slope is -8/5, but we don't know a b value. So we're going to figure that out. And so we're going to take either one of the coordinates, does not matter. Whatever you feel like is the easier of the 2 points. So if this one seems easier or this one seems easier, then that's which ones you want to plug in. Maybe this is easier because it's a 5 versus an 8. So if we plug in this one, our y value is 0. We still have -8/5 times x. X is 5. And we're trying to figure out what b is. Okay, perfect. So to multiply this fraction, it's 5 divided by 5 is 1 times -8 is -8. So then that is 0 equals -8 plus b. We'll add the 8 over to get b by itself. So 8 is our b. Great. We have everything we need. Our slope was -8/5, and our y-intercept is 8. And that is our graph. So if we wanted to check it, we could graph that equation, and it would guarantee, if that's correct, it would pass through both those points. Okay. So let me do one more. Same thing, we got 2 different equations or different points, and we're trying to figure out what's the equation between those 2 points. So what equation would connect the 2? First thing, we need slope. So for our slope, we're looking at change in y's, which is nothing, so 0. And then change in x's from a -3 to a +7 is up 10. But no matter, 0 divided by 10 is 0. Okay, so if we go back into, here's our equation. And then we are going to plug in our slope of 0. So y equals 0, x plus b. And then we pick a point to plug in. And we can figure out what the b is. So it doesn't really matter. Maybe this one, because it has positives, versus this one having a negative in there. Doesn't matter. So whatever you think is the easier of the 2. So maybe I'll throw that in. I have a 7 for my x and a 4 for my y. So 4 equals 0 times 7 plus b. Well, 0 times 7 is nothing, so that goes away. And you're left with b equaling 4. So to finish this off, we have a slope of 0 and a y-intercept of 4. Now don't leave that, because 0 times anything that we ever plug in for x is going to be 0, so that's really just going to go away. And so you have a y just is going to equal 4. And that's your equation. So that's kind of a special case. So actually, if you were to plot these points, they would be, if you went 7 and then 4, and you went -3 and then 4, they're at the same height, they're horizontal. So that's kind of a special case that if you have a horizontal line, your equation ends up just being y equals the y-intercept. And so the y-intercept would be a 4. So it's a special case. It's not like most of the others where you have kind of an angle to it. An angle is going to have everything. You're going to have a y equals mx plus b. But when you don't have an angle to it of any kind, it's horizontal. It's just going to be a y equals whatever the y-intercept is. So it's a special case. So that's not, it happens. And so you can wipe it away. Please don't leave it like that. The cleaner version, the correct version looks like that. All right. All right, we got one more. So find the equation of the line that passes through this point. So same thing, we're going to figure out our slope. Our change in our y's is up 4. Our change in our x's is nothing. Well, that is an undefined slope. That's another special case. So let me look at the visual to this one. That if I were to graph 5, 3, it's going to be something like that. And I graph a 5, 7, it's going to be further up, something like that. It's vertical. Vertical also is not a y equals mx plus b, like a normal kind of a thing. And so when I have this, I really can't even replace my slope with undefined. It's just not a thing. So this one is a special case. I have a vertical line, and that vertical line is hitting the x-axis at 5, because we were out 5. So that actually tells us that is our equation for it. Okay, it's a special case. I'm not going to treat like the others. So if a vertical or horizontal situation happens, it's a special case. It's not going to look like a y equals mx plus b. So it's a recognition, plot our points, and then whatever axis you hit and where is literally your equation. We hit the x-axis at 5. So that is our equation. All right. So that's just kind of a couple special cases. Doesn't happen all the time, but it absolutely does. It happens from time to time.